Okay, so Pythagoras and circles. So we are looking at when triangles are formed, right angle triangles are formed inside circles, and using Pythagoras theorem to calculate some missing sides. So example 1, I need you to take a wee minute just to copy the diagram into your jotters, please. So draw a nice neat circle, and we've got a tangent QP which is connected to a radius QC, and that is connected to the end of the tangent P to form a right angle triangle. Brody said that she can't see the screen. Is anyone else not able to see the screen? Put your hand up if you cannot see the screen. Okay, looks like that might just be an issue for you, Brody. Come out and come back in, maybe. It'd be a good thing to do. Come out the meeting, come back in and see if that helps. I'm recording this anyway. Anything you do miss, you can catch back up when I go over it in the recording. Right, so everyone else can see me, so that's fine. Right, so draw out that triangle within the circle, and it's a tangent at Q which forms a right angle, so I can mark that on there, and I can now use that right angle triangle to use Pythagoras theorem to calculate the distance from P to the centre of the circle C. Now, what the things you need to be looking out for, remember, in a right angle triangle is we need to be able to identify where the hypotenuse is and the two smaller sides. Okay, that's very, very key. In this one, it's pretty easy to see that that's the right angle, so therefore that CP that I'm trying to find, that edge there, that is going to be the hypotenuse, isn't it? So I can call that, it doesn't matter, I've got letters already on here, I can call that C, I can call that A, I can call that B, and that allows me to find Pythagoras theorem. Now, hopefully you remember the formula, it's C squared. Now, if we're looking for C, so therefore we do A squared plus B squared. So you'll need a calculator for this shortly. So the quickest way to do it is we are going to have to take the square root. So what we can do is the square root of, and then just sub the numbers in. That's the easiest way to do it, guys. So 9.3 squared plus 12.4 squared. So it's the square root of 9.3 squared plus 12.4 squared. So if you can do that in your calculator all in a oneer, then that would be best. If not, if you've only got a phone or a laptop, you'll need to do 9.3 squared plus 12.4 squared and then square root the answer. I think most of you have your own calculator, so make sure the square root button is either you're doing a bracket for everything, or if you've got a Casio calculator, you should be able to see that the square root covers the whole line. So just make sure you are taking the square root of both things, and you get this C to be 15.5 centimeters. Easy enough. That's just a basic Pythagoras question. Just got a circle around it. Okay, I don't imagine us having too many difficulties. The problem with these questions is that they can ask these questions in a real variety of ways, and it's not often obvious that you are to use Pythagoras. So let's look at a slightly different style. Example number 2. Again, I would like you to make a sketch of this circle and draw the lines within it. Mark on all that information, please. Okay, so I have a circle, and I have basically, remember when we have a line that's going from one edge to the other that's not to the centre, it's called a chord. So the chord AB, and I have a radius drawn from both A and B to the centre, and then I have a line drawn from the centre O to this point C on the chord, and I'm told that that chord AB is 16 centimetres long. So my question is to calculate the length of OC to the nearest millimetre. That is going to be important in terms of my rounding at the end. in each diagram below. Okay, so the length of OC, so that means I am looking for kind of that length there that I am squiggling over. Okay, so what might be beneficial is to kind of pull that triangle out and make it bigger and just have it on its own. So we know that A to C is the smaller side there, the right angle is there, which means that my hypotenuse is this long side there. I've got O up top here, A is my side there, and B is there. Now, what are my lengths? Well, I know that radius is 12 centimeters, right? And I also know that the chord AB was 16 centimeters and C is right in the middle of it. Therefore, A to C must be 8 centimeters. So now this time I am looking for Pythagoras use a smaller side, not the hypotenuse. I know the hypotenuse. That's okay, Brody. Away you go. So if you remember, the rearranged form for a smaller side is A squared equals C squared minus B squared. So A is going to be the square root of C squared minus B squared. So A is going to be the square root of 12 squared minus 8 squared. Remember, you are subtracting. Remember, the longer hypotenuse has to come first. So carefully put that all into your calculators, and can you tell me your answer, please, in the comments? I want an answer from every single one of you, please. It might give you, if you've got a Casio calculator, it might give you the answer with a root in it. Just hit your S to D button and it should change it to a decimal answer. So the length of A, what is it? Right, I don't have a single answer, so what's the problem? Got one answer. So don't worry about the rounding just yet. I just want to make sure you can put it in your calculator properly. So I know the nearest millimetre. Don't worry about that just now, guys. Just give me the answer that you've got from that calculation, please. And we'll talk about the rounding at the end. Right, okay, so here's what you get out of your calculator. 8.94. Thank you to everyone who gave me that. What you all need to be careful though is that that is not in millimeters. Okay, so 8.94 ... that is still centimeters. Now remember there are 10 millimeters to every centimetre, so the nearest millimetre in this case is actually 1 decimal place. That's what the question means. So yes, it is 8.9, but that doesn't turn into 8.9 millimetres. It would be 89 millimetres. So to the nearest millimetre, it's just 8.9 centimetres. Right? So that's kind of like if you had a money question that the answer was, the answer in pounds was 94.675 and you were asked to round to the nearest penny. It's in pounds and you give your answer in pounds, but the nearest penny is the second decimal place because there's 100 pennies to a pound, so that would be 0.68 to the nearest penny, but it's still in pounds. Do you know what I mean? So in this case, it's asking for the nearest millimetre, which because it's centimetres is the first decimal place, so it's 8.9 centimetres. Okay? I don't really care too much about the specific rounding there. I just, in most of the questions you're going to do, I don't actually think there are any units at all, so as long as you can do the calculation properly, that's all that matters for now. But just try and think about logically what I'm saying there about the centimetres. Right, last one to do. I know we're time's marching on. One more example, slightly different again. This is more using your angles in a semicircle rule. And the question is asking you to calculate the perimeter of the quadrilateral that is drawn within this circle. Okay, so we have P to Q to R to S. We have two kind of triangles in each half of the semicircle, if you like, that form a quadrilateral. We need to find the perimeter, the total distance around the outside of the red shape. Okay, so draw that just now and mark on all that information, and then we'll talk about how to do it. Right, so essentially what we have here are two right angle triangles, don't we? Because the rule that we learned earlier in the week with angles in a semicircle is that PQR is a right angle because it's two lines meeting the edge of a semicircle and from either edge of the diameter, and the same deal is going to be at PSR. Okay, so angle PSR and angle PQR are both right angles. Therefore, it's right angle triangles. Therefore, to find the length, we can use Pythagoras theorem. Okay, so we've actually got two separate calculations to do here. I need to find the length of PQ, and then I need to find the length of SR. Now, they are both shorter sides on the right angle triangle because this centre diameter is the longest hypotenuse length in each of the triangle. So we just need to do two separate calculations in this one basically. So just a wee bit of kind of extra work, but nothing really more difficult. So set up two triangles, and I suppose we're just maybe better keeping them orientated the same way just to avoid any confusion. You don't need to draw the triangles out a second time, I just think it's helpful. So I've got my right angle there, that's S, that's P, and that's R. Well, this is 6.5 centimetres, and that is the hypotenuse, so I'm going to call that C for my calculation. 5.2 centimetres is this one of the short sides, that's going to be B, other short side can be A. So Pythagoras for short side. Minus B squared so 6.5 squared, take away B, which is 5.2 squared, so get me that answer for A. And then we're doing the same in this second triangle, so we've got another triangle P, Q, R. That is 6.5 centimetres again, that is the hypotenuse. Excuse me, R to Q is 2.5 centimetres, that can be side B and missing side A there. So we can maybe call that A2, C2, B2 if we're being specific. So A2 squared equals C2. I'm just calling these like the second set of A, B and C. That's all I'm doing with this subscript 2 here. So don't get confused, please. So it's just the second set of kind of letters really. So A, the second A is the square root of C2 squared minus B2 squared. So A2 is going to be the second value of A, so it's going to be the square root of 6.5 squared take away 2.5 squared. So when you have A1, I guess you would call it, and A2, you can then put together the perimeter. So the perimeter of the shape is just, it's the red shape, so we're not talking about the circle here, we're not looking at circumference, it's the perimeter of the red shape, the quadrilateral. So you just add up all the sides, that's all you do with a perimeter, right? So start wherever you want. P to Q That's what we found from that's A2 here. You've got 2.5, then you've got the first value of A there, and you've got 5.2, so just add them all together. Okay, so let's do the actual calculations and see if your answers match up with mine. So it's the square root of 6.5 squared minus the square root of 5.2 squared. So first length is coming out at 3.9 centimetres. Second length is coming out at 6 centimetres. So perimeter, therefore, is 6 plus 2.5 plus 3.9 plus 5.2. Just add all those together, and that is you finish this particular question. So 6 add 2.5 is 8.5, plus 3 is 11.5, plus 0.9, 12.4, plus 5, 17.4, plus 0.2, 17.6 centimetres. Okay, I would have got you to give me the answers there, but I didn't want to take up too much of your time. You've taken up quite a lot already. But I hope that you did anyone manage to get that last one okay themselves? Can you put your hand up if you managed to get that one okay yourself? Okay. Right, so you can put your hands down now. That's good. So some of these are kind of easier than others. The exercise I'm giving you, you just need to look very carefully at the shape, and you need to pick out your own right angle triangle. Some of them are quite hard to visualize at first, but some of them are a bit easier. Okay, it's kind of developing your problem solving skills. This exercise today, we're going to do it today and over tomorrow as well. Okay, I've just got one last question I want to ask, which I'm going to put in the comments, and I just want you to like whichever one you agree with. One second. Right, so you've got 50-50. I want you to like the comment that you agree with most, just so I can try and get an idea here.